Hello and welcome to CIS 4510 IT Project Management. In this session, we will be addressing the risk associated with IT project in general and the processes needed to identify, analyze, select, implement, and monitor the proper response. Risk is an undesirable situation or circumstance which has both a probability of occurring and a potential consequence to program success. Risks are normally associated with uncertainties. Risk management is an organized, systematic decision-making process that efficiently identifies risks, assess them or analyze them, and effectively reduces or eliminates risk to achieve project goal. The cost of risk varies over project life cycle. For the initial phase, there is a high chance of risk events but low cost impact. At the beginning, you don't know anything about the project, so there is a high risk. The cost for changing any changes will be low. Now, once you get through the project execution and through the different phases, the changes will be very hard. And if we have any risk event that might affect the project, and the cost impact will be very high. When you want to do any change at the beginning of the project, it's easy to be done. When it's already almost approaching finish, then it will be very hard to change and it will be very costly. So the success of the project depends on how well we identify and manage risk. In previous session, we addressed risk management. We did that in like a very high level. We went through some of the processes for risk identification and mitigation, the analysis and mitigation, and the monitoring and control. In this session, we are going to go through the detailed risk management process, and within this slide and the next following few slides, we will address in details how to manage risk. So project risk management processes include the risk management planning, the identification, the analysis, whether it's quantitative or qualitative, the response planning, and the monitoring and control. The risk management planning process identifies the different tools and techniques that will be used to manage project risk. In addition, it will provide mitigation possibilities. The risk management plan will be developed in the initial phase, identifying how to respond to undesirable issues. During project execution, the plan can be revised and updated to make sure that it's covering any possible or new risk. To plan for risk, all information gathered will be needed and used, such as the work breakdown structure, the resource breakdown structure, and the possibility or the responsibility matrix. In addition, the planning team will use the project scope to understand project boundaries and constraints. To plan for risk, the project team will meet with stakeholders, collecting activity-related information and identifying uncertainties and possible risk. The team could also use historical data from other projects with similar activities, or could consult with some experts. Risk management planning will produce the methodology of handling risk and who will handle it. In addition, it will include how much would it cost, the time to handle risk. All this information will be identified and gathered for risk management. For easy reporting, a risk matrix will be developed to include risk categorization, impact, and probability of occurrence. Risk identification process assists in identifying the sources of risk through analyzing project activities. It's the process of identifying what could go wrong. In this process, a list of all possible risks that could affect the project will be generated, which can be done through brainstorming among team members. It is recommended to focus on risk events rather than risk consequences. For example, instrument does not return correct data, which is a consequence of events like poor circuit design or incorrect or failed component, poor software poor software implementation. It's also recommended to first focus on overall project risks, then identifying specific risks. The team should use work breakdown structure to help organize risk identification process. The team should also seek input from sources outside their group. There are many tools and techniques for risk identification, such as brainstorming with the project team, Delphi techniques, where a questionnaire distributed to experts, responses are summarized, then anonymously it will be recirculated among the experts for comments. This technique is used to achieve consequences or consensus of experts and helps to receive unbiased data, ensuring that no one person will have undue influence on the outcome. Interviewing stakeholders and involved personnel is very important to collect the information about risk, possibilities, and uncertainties. In addition, we can analyze the root or the cause of risk. So we can identify a problem, discovering the causes that led to the problem, and then developing a preventive action. We can also use what's called a checklist analysis, which can provide ideas for risk on a current project. Actually, checklists can be developed based on historical information, knowledge from previous similar projects, and from other sources of information. Also, we need to do, or we can use what's called assumption analysis as a technique, and this technique may reveal an inconsistency of assumptions or uncover probabilistic assumptions. We can also use diagramming techniques such as cause and effect diagram, system or process flowchart, influence diagrams, that's a graphical representation of situations showing the causal influence of relationships among variables and outcomes. We can also do SWOT analysis, which is strength, weakness, opportunity, and threats. We can do expert judgment. We can use that as a technique, which is individuals who have experience with similar projects in the not too distant past way or past projects that may use their judgment through interviews or risk facilitation workshops. In the risk analysis process, risk can be categorized to quantitative and qualitative risk. In addition, in this stage, risk priority can be identified. Qualitative risk or qualitative risk analysis is the process of prioritizing risk for further analysis or action by assessing and combining their probability of occurrence and impact. While quantitative risk analysis is the process of numerically analyzing the effect of identified risk on overall project objectives. It's also important to know the impact of risk on project activities and the project itself. The impact will be associated with the probability of occurrence for that risk. The tools and techniques that can be used in qualitative Risk analysis are risk probability and impact assessment, which is the probability of investigating the likelihood that each risk will occur, while impact investigates the potential effect on a project objective. And then we can use probability and impact matrix, which is used to prioritize risk for further quantitative analysis and response based on their ranking. Risk data quality assessment, which is a technique that can be used to ensure the accuracy and credibility of data used in the qualitative analysis. And then we have risk categorization, where the risk can be categorized based on the source of that risk. Risk urgency assessment, which is used to indicate the time to respond or to response, including symptoms and warning signs and the risk rating. And then the expert judgment, which is a technique used where experts are required to assess the probability and impact of each risk. Not all risks need to be subject to monitoring and control. Actually, we can use scenario analysis to assess the risk event impact and develop a matrix that can determine all consequences and their severity if the event happens, identify when during the project will the event likely to happen, estimate the probability that the risk event will occur, and then determine how difficult it will be to detect the event occurrence. We can rank risk importance in matrix as the one shown in this slide. This matrix is called probability impact matrix, which can be helpful in prioritizing risk, where it identifies the event probability versus consequence impact or slash impact factor. In this matrix, we have three zones. The red zone identifies the most important event, which is the immediate response. It needs an immediate attention or immediate response. The yellow zone lists risks that are moderately important and it need to be monitored closely. The green zone events probably can be safely ignored, not affecting the project execution, but that doesn't mean totally ignoring them, but also monitoring them in case that they will move as green to the yellow and then to the red. So always keep a close eye on all identified or possible risk. This slide explains the likelihood and the consequence criteria that is used to judge where to position the risk in the matrix. So for example, this table here shows the different levels and the technical performance and then their effect on the schedule and the cost, and that's why they are ranked from 1 to 5. Based on that, we can actually identify the consequence in this matrix between the low, the medium, and the high, based on the number that I will get from this likelihood, or I mean this consequence. Then we will look at the likelihood table, and based on the likelihood to happen, we can also identify the y-axis or the vertical axis number and identify the exact point that will intersect the consequence with the likelihood, and based on that we will know in which area or which zone the risk located. This is an example of the risk worksheet, which includes a summary of risk description, risk source, risk impact, and the action taken to mitigate risk. Even if you would like to monitor after the action, then you can actually print everything in the current status here to make sure that you are following the implementation of the risk response in place. As a result of the qualitative risk analysis, we can get updates for the risk register, for the plan. We can understand or identify causes of risk. We can get a relative ranking or priority list of project risks. We can get the list of risks requiring immediate response, and we can get a list of risks for additional analysis and responses needed. All these will reflect on the risk plan, and the risk plan will be updated to reflect these changes. In the quantitative risk analysis, we use the following tools and techniques: data gathering and representation techniques, which is interviewing and probability distributions. And then in the quantitative risk analysis and modeling techniques, we use sensitivity analysis, expected monetary value analysis, and modeling and simulation that can actually analyze for us the quantitative data that we have. And then we can also use expert judgment. Again, expert judgment is using expert opinion to judge the risk that we have. The benefits of performing quantitative analysis are the probabilistic analysis of the project, the probability of achieving cost and time objectives, the prioritized list of quantified risks, and the trends in quantitative risk analysis results. In the risk response planning process, alternative solution will be identified, including the outcome of implementing each solution. The response plan will help decision makers and project managers to select the proper response to minimize or eliminate risk. A risk response plan identifies the primary components necessary for managing the risk. For example, what response strategy will be used? How will the risk event be detected and the response triggered? What plan will be put in place in response to the event? And who will be responsible for monitoring and controlling the risk? This is an example of a matrix that will help in identifying the response and who will be responsible for the response mapped to each risk event. The tools and techniques that can be used to respond to risk are selecting a strategy or a mix of strategies that most likely to be effective for addressing certain risks, such as strategies for negative risks or threats such as avoid, accept, mitigate, transfer, strategies for positive risks or opportunities such as exploit, share, enhance, accept, contingent response strategies. All these strategies, the three of them, the negative, positive, and the contingent, will be explained more in the next few slides. In addition to, again, expert judgment, which is the input from a knowledgeable person to the actions to be taken on specific defined risk. Always we can depend on the expert judgment. For the negative risk response strategies, avoid risk means risk can be also avoided by clarifying requirements, obtaining more information, improving communication, or acquiring expertise. Changing project management plan to eliminate the threat entirely, or isolate project objectives from risks impact, or change the objective in jeopardy, for example, reducing the scope or changing the methodology of execution. And also we can resort to shutting down the project, and that will be the last resort to avoid risk. Also, we can accept a risk. which means that not to change project management plan and deal with the risk as they occur, or unable to identify the proper response strategy, and project team will deal with the risks as they occur. Mitigate risk, which means that actions are taken during the project to either reduce the likelihood of a risk or reduce the impact of the risk. For example, testing technical component after receipt would reduce the likelihood that bad part would be used in a circuit. Transferring risk, which means risk is assumed and managed by a unit outside the immediate project, or in other words, maybe outsourcing to a company that's expert in this area. For positive risk response strategies, exploit, which means eliminating the uncertainty associated with a particular upside risk by ensuring the opportunity definitely happens. For example, assigning the most skilled and experienced people to the project. Sharing risk, which means multiple units associated with the project assume some portion of the risk. It's like splitting it into pieces so it will be managed easily. Enhance risk, which means this strategy is used to increase the probability and the positive impact of an opportunity, identifying and maximizing key drivers of these positive impact risks to increase the probability of their occurrence. Example, adding more resources to an activity to finish early. Except in this case, which is the positive, different than the negative, which is taking advantage of the opportunity if it comes along but not actively pursuing it. For contingency planning, risks associated with the technical aspects of a project can have the most severe outcomes. In this case, it can be mitigated by building and testing prototypes of critical components. We can have available backup or alternate designs that have much lower risk. Also, risk associated with the schedule, which is usually required to trade off. In this case, we manage slack time to provide resources for delayed components, or we can bring in more people, which might also increase cost or reduce the performance. Risk associated with cost, which is usually a result from estimate errors and omissions. At that point, time and cost are related, which needs a trade-off of schedule delays with lower cost. In this case, we can descope options that remove components of the project but still allow the primary mission to proceed. All budgets, mass, power, schedule, cost should include a reserve percentage that can be expended as risk event occur. The results of the risk response plan will be updating the risk register, the project management plan, and the contractual agreement of needed, or if the agreement need to be changed, just if needed. Once the project manager selects the proper response, the response will be implemented and risk mitigation will be monitored to make sure that the implementation is correct and no new risk being identified. The selected response will be evaluated for effectiveness and results will be documented to be used for report generating and as historical data that can be used as a reference for future projects. There should be continuous monitoring for the risk to identify potential risk events early in a project. Each risk is assigned to a specific person who has the expertise and authority to identify and respond to an event. Identified problems should be immediately reported, embraced, and solved. Changes in any aspect of the project need to be documented and communicated, identifying who will have the authority to approve a change and who will be notified of what changes and when, and who is responsible for that response or that problem. A written form to track hardware, software, and document changes will be used. The tools and techniques that can be used to monitor and control the risk are the risk assessment, risk audits, variance and trends analysis, technical performance measurements, reserve analysis, and status meetings. As a result to risk monitoring and control, the risk register will be updated, changes will be documented, and corrective and preventive actions will be recommended. In addition, organizational assets and the project management plan will be also updated. So with all that, actually we identified the risk, we analyzed it, knew the impact, have the strategies or implemented the strategies for the right response, and once we implemented the response, we monitored and controlled that response to make sure that it's effective and being implemented correctly, and then we got the proper results for future reference. That will be all for this session. If you have any questions, you can email it to me. Thank you and have a great day.